limit and continuity of two variable function. Before I start with limit of two variable function, I will take you back to the limit of single variable function, where limit is defined as limit x tending towards a fx is L, which means when x is approaching any arbitrary point a, then function fx is approaching the limit L. For example, if fx is any function as shown in this figure, here we have any arbitrary point x equal to a, and L is the limit. Now, to approach this point x equal to a, we have, in case of single variable function, we just have two paths. One is coming from the left hand side and another way is coming from the right hand side. So if we approach x equal to a from the left hand side, then the value of function, here it is L, is same as the value of function when we approach from right hand side, from this side. The value of function is again L. Then we can say the limit of function fx when x is tending towards a is defined, and that limit is L. Now I am taking the another function fx, and it is something like this. This is any arbitrary point a, and it has two values here, suppose k and p. Now for this function, if we approach x equal to a from the left hand side, then the value of function is k here. It means limit x tending towards a minus fx is k, and if we approach this point x equal to a from the right hand side, then the value of function is p. So limit x tending towards a plus fx is p. Here for this particular case, limit x tending towards a minus fx is not equal to limit x tending towards a plus fx. It means limit of the function when x is approaching a does not exist. See, from the graph you can also see that there is a discontinuity here. That's why the limit does not exist. Similarly, we will define the limit for two variable function. Now if f is function of two variables where x and y are the independent variables, so This is the xy plane, and function is defined along z-axis. This is fxy. And limit of fxy when x and y are approaching any arbitrary point. For example, it is 0, 0, 0, 0 here is L. Let us draw a function. This is the three-dimensional plot. Suppose this is any function fxy, which is function of x as well as y, and it's at 0, 0, the value of function is L here. Now in case of two variable function, we can approach this point 0, 0 from many ways. For example, we can approach this point from the x-axis. This is the case for y-axis, and we can approach this point from x-axis, where x is, y is constant. We can also approach this point through this line where y is x. This is straight line passing through origin with slope 1. We can also approach this point through another straight line where y is minus x, or through a parabolic curve where y is x square. So to approach the desired point, we have infinite number of ways, and if the function fxy gives same limit all the time, then only the function then only the limit of function exists. And if the value of function is not same all the time, then limit of function fxy does not exist. For example, fxy, say we'll find out the limit of function x to the power 5y plus 3xy, where x and y is tending towards a point 1, 2. Now to solve this problem, first of all, we'll substitute x and y, value of x and y directly, and if it is a finite value, then there is no problem. That value will be the limit. And if it is, after substituting the values of x and y, if it is in indeterminate form, then we will have to solve the problem in different manner. Here I am substituting the value of x and y directly. So x is 1 to the power 5, y is 2, and then 3, x is 1, y is 2. So this is 2 plus 6, that is 8. So limit for this function when x and y are approaching point 1, and 2 is 8. Now let's take another example where x and y are approaching point 1, 1, and the function of x and y is xy square divided by x square plus y to the power 4, and we have to find the limit of this function. Now again directly substituting the values of x and y, let's see what will happen. This is 1 square, x is 1, y is also 1 square plus 1 to the power 4. So in numerator we have 1, denominator 2. So 1 by 2 is finite number. So this is the limit for the given function when x and y are approaching 1 1. Now let's move on to the next example. X and y, sorry, x and y are approaching 0 0, and the function is x square minus y square divided by xy. We have to find out the limit of this function. If I directly substitute the limits, then this will be 0 minus 0 divided by 0 minus 0, that is 0 by 0, or indeterminate form. So to solve this problem, let's try to find out the factors. Factors of numerator. See, x square minus y square can be written as x minus y into x plus y divided by x minus y. So here from numerator and denominator, x minus y will be cancelled out. We are left with x plus y, and after substituting the limits, this will be 0 plus 0 or 0, and 0 is finite number. So this will be the limit of given function x square minus y square divided by x minus y. Now let's see the next example. Limit x tending to x and y. Here x and y are approaching the point 0 0, and the function is x square minus xy divided by square root of x minus square root of y, and we have to find the limit. If I directly substitute the values of x and y, then this will be 0 minus 0 divided by 0 minus 0. This will be again indeterminate form. So let's try to find out the factors. Or better to rationalize the denominator polynomial of this function, x square minus xy square root of x square root of y into square root of x plus square root of y divided by square root of x plus square root of y. So this will be x square minus xy, denominator will be square root of x square minus square root of y square, so x minus y, and in numerator we have square root of x plus square root of y. This will be, if I take x common, then x minus y square root of x plus square root of y divided by x minus y. So we can cancel out x minus y from numerator and denominator. Now substituting the limits, x is 0 into square root of 0 plus square root of 0, that is 0. So 0 is finite number and it is defined. So the limit for the given function when x and y are approaching 0 0 is 0 again. Now let's see the next example where x and y are approaching point 2 0, and the function is y divided by x plus y minus 2. We have to find the limit. Okay, so if I directly substitute the values of x and y, then this will be y is 0 divided by x is 2, y is 0 minus 2. So this will be in 0 0 form, which is indeterminate form. Now to solve this problem, what we will do, we will approach the point 2 0 from y-axis, where x is constant. We will keep x as 2, and we will approach the point y0 from x-axis. Suppose this is x-axis and this one is y-axis, and the point is x2 and y0. This is the point, and here we are approaching the point through the line which is parallel to y-axis, where x is 2. Okay, so x is fixed, y is tending towards 0, y upon x plus y minus 2. So I can substitute the value of x. Now this will be y tending towards 0, and y divided by x is 2. So plus 2 minus 2 will be cancelled out. So y by y is 1. So this is limit y tending towards 0, y by y is 1. So the limit is 1 here if we approach the point through a line parallel to y-axis. Now what we will do, we will approach the point 2 0 by keeping y 0 and x tending towards 2. Through x-axis we will approach the point. So now this is the first case. For second case, limit x tending towards 2 and y is 0. This is y upon x plus y minus 2. We can substitute the value of y, and if I substitute the value of y, then this becomes 0. Okay, so the function is, this function is giving two different limits. If we are following different paths, then the function is giving different limits. Through this path, limit is 1, and through this path, limit is 0 here. Limit is 0. It means the limit for this function does not exist. Now let's move on to the next example. X and y are approaching the point 0 0, and the function is x square minus y square divided by x square plus y square, and we have to find the limit for this function when x and y are approaching 0 0. Now if I substitute the values of x and y, and then this will be in 0 0 form, indeterminate form. So we will try to reach this point through different paths. Now keeping x constant and x 0 and y is tending towards 0. So limit y tending towards 0 and x is 0. So y square minus y square by y square, this will be minus 1. If y is tending towards 0, the limit is minus 1. Now we'll follow the different path where x is tending towards 0 and y is fixed, y is 0. So x is tending towards 0. Now we'll keep y 0. So x square minus 0 square divided by x square plus 0 square. So x square by x square is 1. So here limit is 1. It means if we approach this point 0, 0 from the two different paths, then function is giving different limits minus 1 and plus 1. That's why the limit of the given function fxy does not exist. Let's see another example. Limit x, y tending towards 0, 0 and the function is xy divided by x square plus y square. See, if we directly substitute the values of x and y, then this will be in 0, 0 form, 0 by 0 form, which is indeterminate. So we'll approach the point 0, 0 through different path through y-axis. So limit y tending towards 0 and x is 0. So this will be 0. Now we'll keep y fixed and x is tending towards 0. It means we are approaching 0, 0 through x-axis. So x tending towards 0, y is 0. So this is also 0. Okay. So if we are approaching the point 0, 0 through two different paths, then function is giving the same limit. Now let's try one more path, A, B and C. Third path is through straight line passing through origin. See, we have to select the path in such a way that the point 0, 0 must lie on that path. Okay, so we can choose a path y equal to x, and if I substitute y equal to x, then x should tend towards 0. X, y, this is the path y equal to x, and we have to approach 0, 0 point. Okay, if y is x, then x is tending towards 0 to approach the point 0, 0. So we will keep y equal to x and x is tending towards 0. So y is x. So in numerator we have x square, and in denominator again y is x. So this will be x square. So limit x tending towards 0. This is x square divided by 2x square, or limit x tending towards 0 1 by 2, that is 1 by 2. See, if we approach this point 0, 0 through y-axis, then the limit was 0. If we approach the point 0, 0 through x-axis, then the limit was 0. And if we approach the point 0, 0 through straight line y equal to x, then the limit is 1 by 2. It means the function is not giving the same limits for the different paths. It means limit for this function does not exist. Let's see the next problem. Limit x y tending towards 0 0, and the function is x square y divided by x to the power 4 y square. See, this is in 0 0 form. If I substitute the limits directly, so we will try different paths. X is 0 and y is tending towards 0. Okay, it means we are approaching the point 0 0 through y axis. Y is tending towards 0 and we are keeping x 0. Okay, so limit y tending towards 0, x is 0, so this is 0. Now we'll try a different path where x is tending towards 0 and y is 0. Okay, so we are approaching the point through x-axis where y is 0. X is tending towards 0 and y is 0. So limit x tending towards 0. If y is 0, then this will be 0 by x to the power 4. That is 0 also, 0 again. It means for these two paths, function is giving the limit 0. So let's try another path. Y equal to x. We are approaching the point 0 0 through straight line passing through origin with slope 1, y equal to x. If we substitute y by x, then x is tending towards 0. So limit x tending towards 0 where y is x. So this will be x, y is replaced by x. Okay, or better to approach or choose the curve in such a way that the order of numerator and denominator polynomial will be same. So instead of taking y equal to x, let's take y equal to x square path. Through the parabolic path, we will approach the point 0 0. We are just trying to make the order of numerator and denominator polynomial same. Through this curve, we will approach the point 0 0. Y is replaced by x square, so x is tending towards 0. So x is tending towards 0, y is replaced by x square, x to the power 4, y is x square, so this will be x to the power 4 in numerator. In denominator we have 2x to the power 4. So limit x tending towards 0 operating on 1 by 2. So this is 1 by 2. Okay. So if we approach the point 0 0, then every time function is not giving the same limit. In first two cases limit was 0 0, and in third case if we follow this parabolic path, then the limit is 1 by 2. It means limit of function does not exist. Now let's try another example. Limit xy tending towards 0 0, x y cube cos x divided by x square plus 2y to the power 6, and we have to find the limit. If I substitute the values of x and y directly, then this will be 0 by 0 form, indeterminate form. So as usual, we'll start with y-axis. We'll approach 0 0 point through y-axis, where x is 0 and y is tending towards 0. So this will be y tending towards 0, x is 0, so numerator is 0, and in denominator we have 2 y to the power 6, that is 0. For if we approach the origin or 0 0 point through y-axis, then limit is 0. Now we'll approach the origin through x-axis. Y is 0 and x is tending towards 0. So numerator is 0 and denominator is x square. So this is also 0. Now we will try another path, and we will select the path in such a way then that the order of numerator and denominator will be same. So let's make x equal to y cube. Sorry, x equal to y cube. If I replace x by y, then y should be tending towards 0. So limit y tending towards 0, x is replaced by y cube. So y cube into y cube cos of y cube divided by y cube square plus 2y to the power 6. So this is limit y tending towards 0, y to the power 6 cos y cube divided by 3y to the power 6. So y to the power 6 from numerator and denominator are cancelled out. So we are left with cos y cube by 3. If y is tending towards 0, then this will be 1 by 3. So we have tried 3 different paths, and in 3 cases, in first 2 cases limits were same, but in the third case limit was different from the 2 previous limits. It is 1 by 3. So the limit of this function does not exist, DNE. Now let's take the next example. I hope it is last example, where x and y are tending toward point 1 1, and function is 2xy minus 2y divided by x square plus y square minus 2x plus 1. Now we have to find the limit. If I substitute the values directly, then in numerator we have 2 minus 2, that is 0, and denominator we have 1 plus 1 minus 2 plus 1, that is 1. So limit of this function, we can directly find the limit. 2 into 1 into 1 minus 2 into 1. In denominator we have 1 square plus 1 square minus 2 into 1 plus 1. So 2 minus 2, in denominator we have 2 minus 2 plus 1, that is 0 by 1 or 0. So limit of this function is 0. So that's how we find the limit of the function. Now I'll take few more minutes to define continuity. Continuity of two variable function. See, if we have to find the continuity of a function fxy, which is function of two variables at any point x0, y0, then or better to say fxy is continuous function at any point x0, y0 if first f of x0, y0 is defined, second limit xy tending towards x0, y0 fxy exists, and the third condition is limit xy tending towards x0, y0 of function fxy must be equal to fx0, fy0. So these are the conditions for continuity of two variable function at any point x0, y0, which is similar to the continuity of single variable function fx. So this is continuity and limit and continuity of two variable function.